Hi everyone, I'm Bradley Botkin here for another cadet tutorial. Today we're going to depart from our normal cadet specific functionality and we're going to take a short dive into time text formats, why there are so many, what they have in common, how they're different, and I thought that would be useful as a general overview of time text. So here we have our tried and true Sintel captioning project, plaintive violin solo playing. And I'm going to select the export function, file export. And look, the export types, there are many, many of them. WebVTT, SRT, QTText, TTML, SAMI, SCC. The list goes on. And you might ask yourself, why are there so many? Why can't we all just get along and use one format? I don't have a good answer for you other than to say that the beauty of standards is that there's so many to choose from. So let's do a quick look at what they look like underneath. So this is Cadet's editing table, and it uses this internal structure. I've called this column start. We call this column end, and the caption column if you're in a caption project. But really, that's just our own invention. It could have been anything. But when we export a file to a time text file, export the project to a time text file, we have to actually pick a format and we have to follow the format that is understood to be that file's type. So I've got a page over here that is going to take us through that a little bit more easily. Here's the representation of the cadet project, our start column, end column, and the caption column. And we're starting with a look at WebVTT. So WebVTT happens to be the format that Cadet uses, I want to say externally, when you play back in Cadet over here, this caption is generated by the browser because the browser understands that it's inhaled a WebVTT file and it knows how to synchronize all those time codes with the media clip. So Cadet's not doing anything fancy in this case. It's just using the browser to create a media player, and the media player, we do that using a video element and a text track, a text element within the video element, etc. So here we have WebVTT. It happens to be an open standard that's supported through the W3C's careful guidance and supervision. And here's what it looks like. It's nothing more than a plain text file. That is to say, lines are delimited with by new line carriage returns. And it's got a little header up here that identifies itself as a WebVTT file, and it's got little numeric identifiers for each caption. And so, this is a caption. Whoops, this is a caption, and this is a caption. And there's a blank line in between each caption. And the syntax of the WebVTT format is a time code with this sort of format, decimal seconds. It's got a dash dash greater than in between the two time codes. This is the end time. WebVTT allows for some styling commands. A couple of them are here. And then there's the caption. And if it were a multi-line caption, then there'd be a new line here and the second line, and a new line and a third line. So that's the way a WebVTT file looks and operates. So as I said earlier, all browsers support WebVTT via the track element inside a video element when you're building your own HTML player. So if you're coding your own HTML player using a video element, you're going to be using this format. So let's move on to the next format, SRT. Oh, well, SRT, geez, that looks very similar to WebVTT, and that's because WebVTT was based on SRT. So SRT also uses the dash dash greater than in between two time codes. It happens to use a comma delimited seconds format. It comes from the European domain, and but again, it's got the numeric identifier for each caption. It's got a blank line in between captions. It's plain text file, and otherwise it looks remarkably similar to WebVTT. YouTube supports many formats. I have found that SRT is the most foolproof for YouTube. It correctly ignores certain styling commands that others where other formats are not ignoring. So SRT is a good bet for YouTube. I think for Vimeo as well. Uh, and let's see. Let's go to the next one. TTML. Oh, SRT, by the way, is not an open format. It's just out there. It's been in use forever, but it's not maintained. It's not changing. It's not maintained by any standards group. It's just out there. Next one, TTML. So this is the TTML format. This is not really a plain text format. So TTML is also an open standard. It's maintained by the W3C. Stands for Timed Text Markup Language. An earlier name for it was DFXP, but it's the TTML format. It's an XML format for those of you who know what XML is. XML is sort of the markup that's used in HTML pages. And you can see that in TTML, every caption is enclosed within a paragraph tag, a p tag. And there are attributes called begin and end. They're decimal seconds. TTML also allows for quite a bit of stylistic markup. So you can see a little bit of that here. And here's the caption. If it were a multi-line caption, you'd put a break tag. You'd see a break tag in between the two lines of the caption. And it just goes on like that. And I say it's XML and not plain text because this could all be run on. Uh, uh, there's no reason that it has to be organized with blank lines in between. It just makes it easier to read, but it was designed for machine processing. And so that's TTML. As I said, it was the first open standard for time text. Let's go on to the next one. It's called Qt text. Qt text is a legacy format. Qt stands for QuickTime. It's a plain text file delimited with new lines with a blank line in between each caption. It really was specific to QuickTime Player, but it was Apple's version for how you supply captions and subtitles into the QuickTime Player, into a QuickTime movie. And it has a header here that declares itself to be Qt text, and it also allows for some stylistic markup. And here's a time code. It's decimal seconds. The time code has to be embedded in square brackets. And then there's the caption, and it could be multi-line, just like in WebVTT and SRT. Notice in the Qt text format, there's only a single time code. Why is that? The other formats have a start time and an end time when the caption goes away. But Qt text doesn't have that. The syntax of Qt text is just time code caption. If you have the next time code, it comes in, its caption comes in there. And if you wanted to erase a caption, so since there's no end time, you would just have a blank caption. And so there would be a time code with no text, and that would tell Qt text that it's time to erase the screen. So this is, as I said, a legacy format, and but in general, sort of the same as the others. The last format we're going to look at is called SCC. SCC stands for Scenarist Closed Caption. Scenarist was a DVD authoring package originally put out by a company called Dakin. Somebody else maintains it now or owns the rights. It's also it's a plain text file, so it's delimited by new lines. It's got a little header here that declares itself to be a Scenarist file, and it also has time code and caption. Time code and caption. Well, so it's got a single time code, sort of like Qt text, which is to say, at this time code, we start doing this, whatever this is. Well, I'm not going to give you a tutorial on SCC, but suffice to say that these are commands that are intended for a closed caption decoder in a television. So in the broadcast space, closed captions are transmitted as data. They're decoded by a decoder in the display engine. And these are commands that the decoder understands, and they have to do with, put the cursor here, make the font italic, let's say, and then here comes some text. Or, geez, I want to be a roll-up caption, and I want it to be three-line roll-up, and here is some data for that roll-up caption. So these are ASCII hex representations of characters in the ASCII table, and they're either that or specific closed caption decoder commands. But uh, the reason that we're going over SCC format in this tutorial is that it turns out to be quite useful for YouTube. So YouTube knows how to inhale an SCC file. It knows what to do with these funny looking commands. And in particular, it knows how to present a roll-up caption. So you've all seen roll-up captions on television. If you watch the news, it's real-time captions and they're rolling up at the bottom typically. And that's a nice, easy way to read captions. And YouTube knows how to do that. So if you can create an SCC file, a scenarist file, that's coded with roll-up captions, and you import that into your YouTube video, then indeed YouTube will display nice roll-up captions, and you might see roll-up captions on this tutorial right here. It's over there, and that's how we did this. So Cadet knows how to code rollup into an SCC file, and YouTube supports rollup mode in SCC files that are coded for it. So that can be useful, and that'll be the subject of another tutorial. Um, so that's what we have. We've got a bunch of time-coded text formats. They all have in common that they time-code some text, tells the media clip when to display a caption. So they do it a little bit differently. Some have start times and end times. Some of them only have start times. But that's what they have in common. And the format you pick will depend on which kind of player you're trying to target. If you're building your own player with HTML using a video element and text elements, um, then you'll want to use WebVTT. If you're targeting YouTube or Vimeo or someone else's player, that player will determine which format you have to export as. But certainly YouTube and Vimeo both support WebVTT and SRT, and SRT I've found to be the most useful and foolproof. There you have it. Hope this was useful. We'll see you later. Bye bye.